Hi, everyone. I'm Christy Martin, Rachel Carson Computer Science Class of '88, and I serve as the VP of Finance for the UCSC Alumni Council. On behalf of the UC Santa Cruz Alumni Association, I'd like to welcome you to our monthly speaker series, Slugs and Steins, Lectures from UC Santa Cruz. For those who are new, our Slugs and Steins series engages UC Santa Cruz faculty members in discussion with the community. The series began in pubs in Santa Cruz and Silicon Valley, thus the Steins portion of the name, and is now extended to the broader online community. So welcome, and hopefully this will take you back to sitting in class in the Redwoods at UCSC. Our co-organizers, April and David, have the night off, but Mike is here as usual, and he'll be helping with QA later. We'd like to begin by sharing the UCSC land acknowledgement. The land on which we gather is the unceded territory of the Awaswas speaking Yupi tribe, the Amamutsan tribal band comprised of the descendants of indigenous people taken to Mission Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices on these lands and heal from historical trauma. Before we get started, we'd like to take a quick poll to get to know our audience, where you're tuning in from this evening. Please take a moment to answer a few quick questions that'll pop up on your screen, and then we'll share the results after we've given everyone a few minutes to respond. So you should be able to see the poll now and who's in the room with you. Okay. Got Santa Cruz and the Bay Area in the house. Welcome to those calling in from elsewhere. So tonight we raise a stein with Dr. Yi Zhang, Professor of Computer Science and Engineering at UCSC. Her research interests are in personalized search and recommendation, natural language processing, and artificial intelligence. As conversational AI virtual assistants like Alexa and Siri become part of daily life, this type of research allows computers to understand human intention and accomplish increasingly complex tasks. Dr. Zhang is also a co-founder of Rul.ai, a no-code omni-channel conversational AI platform that appeared on Forbes' top 50 most promising AI companies list. She's been a consultant or technical advisor for several large companies and startups, including Alibaba, HP, and Toyota. She's received multiple awards, including ACM SIGIR Best Paper Award, the National Science Foundation Faculty Career Award, Force Young Investigator Award, and awards from Google, Microsoft, and IBM. The professor received her Ph.D. in language technologies from the School of Computer Science at Carnegie Mellon University. If you have questions during the talk, please type them in Zoom's QA box. You don't need to wait till the last minute. Go ahead and type them in at any time. And if you see someone else's question that you like, you can upvote it, and that'll make sure that it gets asked a little sooner. And then we'd like to do one more quick poll just to understand a little bit about everyone's background with AI. Okay, great. Thank you. And just a few logistics. There's a live transcripts feature on the bottom of your screen, so you can turn on closed captioning if you want to enable that and watch speech to text happening in real time. The talk this evening is also being recorded. It'll appear in a few days on UCSC's Arts, Lectures, and Entertainment YouTube channel. Okay, so does everyone have your Stein or your UCSC beer cozy? And take it away, Professor. Thank you.
Thank you for the introduction, and thank you for inviting. Let me share my screen first. Can you see the screen? Okay, I'll show me it works. Let me know if it doesn't work. Thank you for coming to my talk. I just see your survey results. Hopefully this talk would be useful for all of you, no matter whether you have learned machine learning or AI before or not. As we mentioned before, nowadays, conversation AI virtual assistants are in our daily lives, from Amazon Alexa to Apple Siri and to Google Assistant. Actually, my son probably spent more time with them than with me, good or bad. Okay. Especially in the last few years, the coronavirus pandemic lockdown further drives the popularity of those conversational virtual assistants, because as many human agents working at the contact center are sent home, companies are actually steering their customers towards their conversation AI virtual assistants, like those on their websites or over the phone. So maybe sometimes when you are talking with virtual assistant, you don't even know about it. And conversation virtual assistants has been used for many companies and many domains. For example, in connected cars, in education domain, food and drinks, game, health, fitness, home services, movies, music, news, humor, sports, travel, transportation, weather, utilities, and so on and so forth. Just for myself, I have helped launch production live conversational virtual assistants in multiple domains like health insurance, automobile, telecommunication, finance, commerce, and travel, those domains. They are becoming less robotic and dumb, and they are on a path to improve significantly over the next several years. Even now, there are times you sort of cannot tell whether you are talking with a human or talking with a conversation AI virtual assistant. However, as researchers, we know the technologies behind those conversational AI virtual assistants are still very limited. There are still a lot of challenges and problems. So I'm here today to share with you, introduce you how conversational AI virtual assistants learn to work with humans as of today. And I also want to point out later what are the challenges yet to be solved and how I think the future learning should be. If you have any questions in the middle, please let me know. And why virtual assistants are useful? They actually have several major capabilities that make them useful for humans. For example, when a person wants to get some tasks done interactively, for example, buying something, checking order status, signing up for registration, some virtual assistants actually can help the user to finish those transactions. Or when a person is looking for specific information and asks a question, the virtual assistant could also provide the answer. And sometimes when a person is just looking to reach a particular website or location, the virtual assistant can work as an interactive search engine to help the user to find it. Or sometimes if a user wants some suggestions, such as what kind of gift I should buy for my 60-year-old dad, right? Which movies I should watch with my kids. The virtual assistant can actually make conversational with the user and help to make very personalized recommendation interactively. Or maybe sometimes a person just wants AI friends to talk with for social support. The virtual assistant can do some chit chat with the person to provide the social support. Those are the potentials and something skill sets the virtual assistant has developed. And however, most of the tasks you have, the questions you ask, places you want to find, recommendations you need, and the social comforts you want, the capability of AI virtual assistants are still limited. That's why I guess for most of those tasks, you still go to a human or go to search engine. Because today's virtual assistant skills are still limited, although researchers and engineers are working on getting those capabilities well. On the other hand, their potential are big. As in the future, they can do good job in those aspects, they can help us a lot. So in today's talk, I will talk about the latest technologies behind the conversation virtual assistant and how we do it now and how we should do it in the future. So before talking about how the current AI virtual assistant learns, let's talk about what we hope actually a human like an AI agent should be. And we think AI and human have a lot in common. In order to understand how to empower people to build AI workers in companies or working at home, by the way, we call those AI virtual assistant AI workers. How to build, in order to understand how to empower people to build it, let's first look at what makes a good employee, a human worker. A good human worker, a good employee should be smart. Besides, the employee should utilize his or her smartness to take actions and get work done. And the human worker should also be fast learner who can learn quickly and contribute to the company soon. Right? We don't want to spend months or years to train a new employee. We also want employee to be flexible and extensible, can extend to do all kinds of jobs as it evolves. And this is what we hope a human worker should do. And we think AI workers should also be like that. AI workers should be smart, action-oriented, fast, and extensible, which we call SAFe. We introduced this SAFe method for conversational AI workers. And smart means the AI virtual assistant should have ability to have very flexible conversation. And action, it should be able to get tasks done and could learn fast and could be very flexible and extend to do all kinds of works like humans do. However, to build smart AI virtual assistant is pretty hard because of AI virtual assistant, which we also call a bot, needs to understand what a person is asking. And in order to do that, it actually needs to have some domain knowledge, also have common sense, has discourse understanding of a whole conversation, so that it can generate very coherent, meaningful, and a correct response to people's requests. And it also needs to decide when and how to take certain actions to automate certain process, like a business process in a company or a process at your smart home. And it also should be interactive. To get those done, it's pretty hard. Now let's talk about, can today's conversation AI virtual assistant actually be smart or be safe? To answer this question, I want to switch gear to tell you about what today's technologies are. There are actually two types of conversation AI virtual assistant technologies. And the first approach is modularized architectures. Most of the existing work are based on modularized architecture, where an intelligent conversational agent would be formulated as different functionalities and different modules, such as natural language understanding, dialogue state management, and so on, which I will talk in more details later. So a lot of pieces are put together to build a conversational AI virtual assistant. An alternative approach is having an end-to-end learning model. For example, a language model, which we are going to talk later. So let's first look at the first approach, modularized architecture. And here is an example. When a user say, I want to find the Italian restaurant. The first module is called natural language understanding. We'll take this input and convert it into a thematic representation, such as intent is search for restaurant, inform of the variable related is cuisine is Italian. This is the first module of this architecture. And then the second module is called dialogue manager. The dialogue manager takes the output of the natural language understanding here. It take it as its input. It usually maintains some state variables such as what's the dialogue history, the latest unanswered questions, and so on. And this how it maintains its state depends on different approaches. And then the dialogue manager will consult some dialogue policy and generate a output. This output is some instruction to the next module. The output would be request location. And the next module is natural language generation module. The natural language generation module takes the output of dialogue manager, that's like an instruction, and convert it into natural language and send to the user. Where do you want to eat? So as you can see, there are three major components for conversation AI virtual assistant. Of course, the AI virtual assistant should also have external knowledge, like common sense knowledge or domain knowledge. So there will be a knowledge engine. The virtual assistant should also be able to take actions to get something done. So there will be some action engine. However, the core includes natural language understanding, dialogue manager, and natural language generation. Okay, let's first look at the first component, the natural language understanding. As I mentioned before, natural language understanding takes the natural language expressed by the user as input and output a semantic representation. It's usually a structured domain-specific representation the machine can digest. Could be a command language or database query or certain formal logic. Here is an example. I want to fly from SFO to New York on Tuesday morning, or if users say, need a ticket to New York departing from SFO on Tuesday morning, the natural language understanding engine will convert it into this representation. And there are two challenges for natural language understanding engine. The first is there are almost unlimited way to express the same intention. But like for this same intention here, I listed two ways to say it by users. And there are almost unlimited way to say it. And how can machine to understand, to map different ways of saying the same intention into this logical form? It's a challenge. Another challenge is humans are actually unruly, not following rules. They are unconsciously, they actually express their intention in very ambiguous way. And they could also be inconsistent in their communication. And humans are very flexible in their ability. The people who listen are very flexible in their ability to understand those imperfect, ambiguous communications from the other people based on context. So human is pretty good at natural language understanding. However, it's a challenge. This kind of ambiguity is a challenge for machine. Because, for example, the similar sentence could have very different meaning. Like this, a seat is available to every customer versus a website is available to every customer. They actually have very different meaning. This is one-to-one mapping between a seat and a customer. And here is one-to-many mapping between a single website to many customers. And this kind of similar sentence have different meaning, pose a challenge to the machine. And I also mentioned we want to convert natural language sentences into structured domain representation. And here are some examples of the structured representation. One example is this intent and arguments format. Given the natural language, we represent it, convert it into an intent and certain variables. Those are the arguments for the net and for those intent. So the machine just need to recognize the action needed and the associated variables or input for that action. Here is several examples of what this machine could do. And this kind of conversion from natural language to intent and variables is actually a very simple approach. It helps to be simple because then it's robust and it can scale to many applications. And this is pretty common for personal assistant voice commands. For example, if you have interact with smart home devices or Alexa say turn on the turn on the lights at my dining room. Generally, behind it, this kind of thing is happening. Besides this kind of intent and arguments representation of the intention of the user, another kind of structure representation the machine can output is database queries. Database queries is a very standard programming language used to manage relational database and perform different operations on the data in it. And natural language understanding component can also directly map natural language said by human into database queries. For example, if humans say which country had the highest carbon emissions last year, the natural language understanding can automatically convert it into this kind of SQL query. And in order to train such kind of learn such kind of model, usually the machine need to know what's the schema of the query, and then have certain training data, which I will talk about training later. A third way to represent what user said is using procedure language. For example, if user say, go to the third junction and take left, then that will be converted into a procedure language like this. Do sequentially, like do this step, the next step. This procedure language is a computer programming language that follows in order a set of commands. This will express certain concept, nested action sequences. And the natural language understanding should be able to automatically convert this into this representation, this structured representation, so the machine can further process it. Those are three different types of structured representations the natural language understanding should be able to convert. Of course, when we talk about understanding human language in a conversation, usually it involves multi-turns, multi-round conversation. That involves discourse, what we call discourse understanding, which captures the structures and effects in related sequence of conversation, a sequence of sentences. Here is an example. Right? If one person say, look at the boy in the blue t-shirt on the playground, the other person say, oh, blue. Then this person say, yes, he is being chased by your dog and frightened. Then discourse understanding will recognize he referred to the boy, right? Your dog. Later, oh, we should get it back, then that it should refer to your dog. So that's called discourse understanding, which is also what natural language understanding component should be able to do. Now we briefly talk about the first component, natural language understanding, and it output a structured representation of what user said. The next module, dialogue manager, will take that as input and maintain its state. Dialogue manager is in charge of control the flows of the conversation, right? Take the natural language understandings in output as input, and then it has a memory. Dialogue manager has a memory. It updates its memory based on what user just said, and then it might interact with external knowledge engine or action engine and consult dialogue policy rules to decide what to do next. And then we'll generate an action, pass the output to natural language understanding, natural language generation component, the third component. Dialogue manager is one of the core for conversation AI virtual assistant. And it's pretty challenging to build a good dialogue manager to control the flow, because a real conversation can happen in all kinds of different ways. And it's usually unpredictable. Dialogue manager with AI technologies are needed to make the conversation more like a human conversation. Here is a simple example of what dialogue manager can do in the case of recommend a movie. If user comes say, find me the Bill Murray's movie, and there is a database of movies, the system, the dialogue manager could consult and decide, say, what I should do, right? You can either select answers or ask him for some clarification questions. And if the dialogue manager actually say we should ask questions, then it also need to decide what questions to ask. Shall we ask movie title or release year? Like in this case, dialogue manager actually output say, ask for which year it's released. Then the bot will say, when was it released? Then the customer say, I think it came out in 1993. And then the dialog manager feel it has this uncertainty and then decide to go to consult the database and return back the results. So this is just a very simple example. So how can we build dialog managers? What are the different approaches to solve dialog manager? There is no single solution. Here are certain different approaches researchers and engineers have implemented to build the dialog manager. For example, finite state, like a rule-based approach seems somewhat dumb, but it's actually one of the most popular ones. And frame-based is becoming widely adopted by big companies. And there are also other dialog manager strategies like information state, AI planning, neural networks, and hybrid. Due to the time constraints, I'm not going to cover all of those. I'll give you two examples. Remember, the main role of dialog manager is to decide what the next action should be so that it can pass that order to the natural language generation component. And a simple way to do this is just let designers or people to write completely specify the dialog structure like a flowchart. This is the finite state rule-based approach for dialog manager. And in this approach, dialog manager just keeps a pointer to our current position in this flowchart, and it will update according to the input from the user and move to the next state. If we use a rule-based or finite state-based dialog manager, then the virtual assistant will completely control the conversation with the user. It will ask the user a series of questions, and maybe ignore anything the user says that's not directly answer the system request. This is what we call system ask user response setting, and it's called machine initiative. And why people do this? Because it's simple. It's simple, user knows what they can say next because dialog manager is generating requests to ask. And this is okay for very simple tasks, but it's too limited. And we all know the real conversation really involves give and take, which we call kind of thing is machine initiative. The machine is leading the conversation. Sometimes some system will give a little bit flexibility in that user to say certain common commands like help, start over, I need to change. Right? Those common commands add some flexibility, but not too much. On the other hand, in certain situations, it's actually better to let the users, take the initiative and control the flow of the conversation. For example, in voice commands or voice search scenario, this is called user initiative, where user will direct what to do next instead of the conversation AI virtual assistant. The virtual assistant won't be able to ask questions, engage in clarifications, and so on. Of course, we know user initiative or machine initiative are not good. Right? In a natural conversation between people, both parties might be able to lead the conversation. And we also hope an intelligent conversation AI virtual assistant can support this kind of mixed initiative where the conversation leader could switch between the two parties. This is called mixed initiative. And the state flow chart we mentioned before for dialog manager won't be able to support mixed initiative. Now let's talk about the next alternative approach. There are actually several different approaches to achieve this mixed initiative conversation. And I would like to just mention the simplest way to do that. But it's also a very popular way. It's called frame-based dialog manager. Let's consider a task-based dialog manager in which the dialogue system, the conversation virtual assistant, has a goal of helping a person to solve a task, for example, making an airplane reservation, right? And in this scenario, a frame is a kind of knowledge structure representing the kind of intentions the system can extract from users' utterance, what user said. And it consists of collection of slots, like original city, right? And each of which can take a set of possible values, like city is a value. And next to it is there is a question the virtual assistant can ask the user in order to get that information. Right. And a popular dialogue manager strategy used in various systems like Apple Siri, Amazon Alexa, and Google Assistant is designed around this kind of frame. The system's goal is to fill the slots in the frame with the fillers user intended and then perform relevant actions based on what's collected. To do this, the system will ask the questions, right? Will ask the questions to the user using those pre-specified questions template associated with each slot of each frame and filling up any slot that the user specified based on natural language understanding components we mentioned before. And if a user actually responds in one sentence tells multiple values of multiple slots, then the system will fill multiple slots. And when it comes to the slot that has already been filled, the system will skip questions associated with those filled slots. So that's called a frame-based approach. It's one of the popular approach used by today's personal assistant. And now, after dialogue manager, right, and take the input of natural language understanding, send the action to the natural language generation module. The next module is called natural language generation. The natural language generation need to generate sentences that to be presented, said to the user. There are always existing some challenges for generating language. And because the responses should match with the context knowledge, should match with the current conversation. And on the other hand, it have to be consistent. Right? And it's also very bad if you have a response that looks consistent with the context, but doesn't have any meaning. It's also a waste of people's time. So we actually need to make a balance between having consistent output to the user, but meanwhile have informative response to the user. How to do that? There is no perfect solution. There are just two very different approaches for current system. One approach is retrieval-based approach. Right? For this group of approaches, this is a group of methods. They're called retrieval-based method. First, the system will have a collection of past conversations. Those could be past conversations between human and human. And then you treat those past conversations as examples of responses. And now when a conversation AI virtual assistant talks with a human, you treat what user said and the context at each round as the search query. Then you use that search query to search against collection of past conversations and find the signal context. And then repeat some appropriate responses from existing past conversation. Behind it, you have the current context, then you have candidate responses from the past collections. And if some matches, you generate a response score and you rank the past conversations, right? The top ones or top multiple will come out. And this kind of approach has the advantage to be fluent and informative, relevant to the conversation context. However, it's less flexible since the responses are selected from predefined pools of data sets. And a second approach are generation-based methods. Those methods tend to be more flexible and can scale to generate new sentences as reply to the user. And there are actually two approaches to generate new sentences. The first approach is template-based. In template-based approach, maybe some handwritten template were predefined with certain variables need to be filled based on the conversation context. then natural language understanding or natural language generation will just generate based on field template. A second approach are machine learning based approach where every word were generated on the fly. And I will talk more about it later. Okay. Generally, it's formulated as a sequence to sequence generation neural network models, and the responses could be generated totally new. And of course, there are pros and cons for different approaches. And here, there are people also combine them together, a hybrid approach. Now we talked about the three components of modularized conversation AI assistant. And you might ask, why we have those three components? Can we just have a giant AI brain like human and does everything needed together? The answer is maybe yes. Researchers and engineers in conversational AI are actually doing research on this kind of end-to-end solution. Instead of having different modules, let's just have one giant brain. Recent end-to-end dialogue agents attempt to map actually directly from the conversation history to response to the user or certain API calls if certain actions need to be taken. But in order to understand how to do this, build this giant brain, just do everything into one model, we have to go over basic machine learning first. Based on the survey, it seems quite a lot of audience haven't learned machine learning yet. So let me spend some time to talk about the basics of machine learning. In order to understand, so that we can understand. Okay. The main technique for machine learning is called supervised learning. For supervised learning, we first need to train a model. How to train it? We will give some input variables and output variables. Those are input-output pairs. We give it to the machine's brain, and then the brain will machine's brain will learn some model, infer a function from the training data. Okay. This function will be able to map the input, take input, and predict the output. It infer a function. This function has the ability to predict. Then later, if a new case comes in without a label, we don't know whether it's Apple or not, then we can use the model to train the function and give this input, and it will give us the output whether it's an Apple or not. And this is called supervised learning. So besides supervised learning, which is the most basic machine learning technique for machine to learn how to make predictions from training data, which are input and output pairs. There are also other approaches. For example, the next approach is unsupervised learning. It's a kind of algorithm that learns patterns from unlabeled data, from data without human label. The hope is that by mimicking, which is an important mode of learning even for human beings, the machine is forced to build a compact internal representation of its world and then generate an imaginative content from it. And it learns by mimicking. And another kind of approach of learning is called reinforcement learning. This learning method is for intelligent agents, like a conversation AI virtual assistant, that need to take actions in an environment in order to maximize some cumulative rewards over time. Reinforcement learning differs from supervised learning in that it doesn't need labeled input-output pairs to be presented. And it also doesn't need suboptimal actions to be explicitly corrected. Instead, the focus is to finding a balance between exploration, which is try to explore uncharted territories, and meanwhile doing exploitation of use the current knowledge to get a reward. And reinforcement learning is one of the three basic machine learning paradigms, together with supervised learning and unsupervised learning. And there are many different methods for supervised learning, unsupervised learning, and reinforcement learning. And the state-of-art learning method is called neural network. Sometimes people also call it deep learning. It generally implements learning as a process of gradually adjust a neural network parameters, which we are going to talk in more details later. And although those methods, deep learning method, has been very popular and been successful in many tasks, they haven't been as effective as human. They can reach human level performance on some challenging benchmarks. They are still from human-like, because deep learning neural networks often need more data than human do in order to solve the same type of problem. For example, in order to learn the meaning of words in their native language, children make a very meaningful generalization from very sparse data, which we call like one-shot learning or few-shot learning, where short means the number of labeled training data. You just show children 1 or 2 apples, the children will be able to predict future apples. In contrast, existing learning methods like neural networks need a lot of data. And they are very notoriously data hungry. How to solve this problem? There is another learning technique machine can do. It's called transfer learning. Transfer learning is a technique to improve the learning in a new task through the transfer of knowledge from a related task that has already been learned before. With pre-trained models, machine might achieve zero-shot learning, one-shot learning, few-shot learning in a new task by transferring what the machine has learned from other tasks. And another very common frame in order to solve the problem of data-hungry learning method is to achieve 0, 1, or few-shot learning is called meta-learning. And the meta-learning, and in meta-learning, then the AI virtual assistant, or in general, AI system, can learn a model from a collection of many tasks, and each task only have a small number of training data. This is kind of like human learning. We learn a lot of tasks, and in each task, we don't have too much training data, and that's called meta-learning. This is believed to have the key advantages of forcing the learning, the virtual assistant, the learning AI system to make training objective to be consistent with the testing objective and to generalize from multiple tasks. So those are the basic learning methods conversation virtual assistant can use to learn their model. Why I say that? Because I want to show you how we do end-to-end solution. Okay. As I mentioned, the most popular approach that performed really good is neural networks deep learning. Okay. This is motivated by a human brain. Human brain has a collection of, on average, 86 billion highly connected neurons. And similarly, some state-of-art AI systems brain is a big artificial neural networks. In this big artificial neural networks of billions of neurons, each neuron is the basic computing unit. Within the artificial neural networks, a neuron is actually a mathematical function that models the function of a biological neuron. Typically, a neuron will compute a weighted average of an input. Its input, here are the inputs to a neuron, and here are the parameters of this neuron. And a weighted average of the input is summed and passed through a function, usually a nonlinear function, to generate some output. This is what a computational neuron does. And then when we combine many neurons, like billions of neurons together, we can get a neural network. Here is an example of a neural network. And each node is a single neuron. For each neuron in this neural network, it takes input from the previous neuron and do some transformation and generates output sent to other neurons. So that's a neural network. The question is, how can a computer, for example, a conversation AI virtual assistant, build such kind of neural network? And how to do that is through supervised learning. This is an iterative process. And here in this process, we should have some training data. Training data are input-output pairs. Here, each row is a training data point, has some input. This is one input, which has 3 variables, and it has output, which gives the label. 0 could stand for no, and 1 stand for yes. Okay. And to learn such kind of neural network, what's the machine do? The machine can initialize the parameters randomly. And then it iterates over this data set of input. At each iteration, at each point, it will select a training data point, select a training data point, feed it to this neural network, feed the input into this neural network, and then each neuron does some calculation, pass the output to the other neuron, and they keep on take the input, pass to the output, and so on. And finally, we'll come to here, generate an output. Right. And we look at the output from this neural network for this input, and then compare it with the true label, which is 0 in this case. And the neural network will calculate a loss, which is the error. How far is the output from being correct? In this case, is 0.9. And the neural network will then propagate it, we call a gradient, back into the network to correct the parameters, where each link corresponds to a weight. The weight of the network will be adjusted based on the gradient, calculate based on the error. This kind of neural network is a very highly flexible function approximator. And the parameters of neural network are found through this whole process, which we call stochastic gradient descent. Its approach, why we call it stochastic gradient descent, because it replaces the actual gradient by an estimate based on this error. And this whole process, as you see, we just process one data point, then we adjust the weight. This reduces the very high computation burden and achieve the learning much faster. So for each training data point, the neural network could be trained and improved. So that's a basic about learning using neural networks. And a special neural networks architecture called transformer now is a winning solution for many natural language processing tasks. People have trained very large, deep neural network transformers based on what we call language models, with millions or hundreds of billions or even trillions of parameters, and pre-trained to predict what's the next token. This is kind of unsupervised, but you have a tons of training data from the internet. You can get a lot of sentences on the internet, and at each position of a sentence, you will predict what's the next token based on what's written before it. And so here is an example. A group of researchers trained a neural network with 1.6 trillion parameters. And they get 180 billion target tokens, generally 180 billion training data. Those data are text data gathered from the web. And those kind of huge models trained from huge, almost unlimited volumes of accessible text data gathered across the web has demonstrated pretty strong learning ability on many natural language tasks. Those models seems to have figured out the deep structure of language, sometimes even well above or below the level of anything human can understand about their own language. And huge language models like this have delivered amazing results in natural language processing tasks. They can be used to write stories, poems, answer questions, translate languages, of course, writing responses for conversation AI virtual system. And here, for those, how to use those giant language models to do conversation AI virtual assistant. To do that, usually people will further learn from many few short generate tasks, generate many tasks with a few small training data. And those different tasks will force the model to generalize across tasks. And then there are approaches called the prompt design. Human will design certain prompt to trigger the big language model, big neural network to say something following up, like continue a conversation. You know, some chatbots, for example, Lambda is a large language model that is designed to predict the likely next word to whatever line of text it is given. Because many conversations are somewhat predictable, those systems can infer how to keep a conversation going productively. While those huge language models trained, those neural network models trained are very promising, but they haven't outperformed the modularized baselines, the approaches we mentioned before, in certain serious benchmark conversational AI evaluations yet. There are promising results coming from hybrid approach called neural symbolic dialogue systems, which combines deep neural network with symbolic reasoning to do conversation. And we expect more innovation will actually be developed in this direction to eventually make the direction into real serious applications. Now they are very interesting things for researchers. Besides using those gigantic learned neural networks to do end-to-end learning, I also want to mention they can also help the modularized approach we mentioned before. Researchers have adapted them to modularized approach. To do that, each module of the conversational AI virtual assistant can be learned using the machine learning techniques we mentioned before. For example, the natural language generation component we mentioned before can be done using the learned gigantic language model. It takes the input. Here is imagine this is a neural network. It takes the input, confirm name is Hilton, area equals center. This is output from dialog manager, which becomes the input of the natural language generation. It takes it as input, and then at a certain position, in order to predict the next words, it consult everything before it. And in this case, in order to predict the next word will be confirmed. And this kind of model is usually first using pre-trained gigantic large-scale language model, then do further fine-tuning in this particular task. And of course, for this particular task, there are not that training data. That's why we need to actually pre-train it from, for example, billions of predicted the next word task, where we actually have a lot of training data by crawling the internet.
Orlando.
Okay, so far we have discussed two major approaches on how conversational AI virtual assistant learns. Modularized approach, which has three major components: natural language understanding, dialogue manager, and the natural language generation. All the end-to-end solution researchers are working on, which try to learn a gigantic brain to take what user says and the context and input and output the response or API calls. And the machine learning based approach, such as supervised learning, unsupervised learning, reinforcement learning, zero-shot, few-shot learning, transfer learning, or meta-learning, we mentioned before, have been the key methods for training those AI virtual assistants. For modularized model, they are used to train each module, and for end-to-end model, they are used to train the gigantic neural network. So in the last few years, many recent advances have come using the deep learning, big language models train end-to-end in tasks such as natural language generation. And this deep learning model also has been used for training other tasks like video games, board games, or object recognition, and so on, beyond natural language understanding. There have been some for certain tasks, and those virtual AI systems actually have beat humans. And existing techniques, however, for conversational AI are still limited. And we still have a long way to go before getting a real human-like conversational AI virtual assistant. Because here are certain challenges we are facing. First, we know human has very rich knowledge about intuitive physics and intuitive psychology. Those intuition enables us human to have the right expectation on what the physical world should be and infer the beliefs, desires, and intention of other people in the conversation. However, those things are not really there for conversation virtual assistant. And second, as we mentioned, we can train huge neural network models. However, we believe a system trained on language alone, right, trained on predicting what's the next word, although we have hundreds of billions training data. However, we think the system trained on such kind of language data alone is a bit kind of a mirror. It gives the illusion of depth and can reflect almost everything. But if we actually try to explore it in depth, we bump our head. The output of those language models are probabilistic, and they can generate fake facts. And they are probabilistic if they generate one sentence given a context, and if you delete that sentence, you need to regenerate some other sentences, it can generate something totally different and possibly contradicting to what it previously said, because it doesn't have deep understanding of the real world. We think deep understanding should be grounded natural language understanding. It should be able to understand, have the composition ability to understand the world and could understand the causality of the world and link the natural language to real world physical objects and relationships. Those are not there for today's conversational virtual assistant. And researchers are working on that. Another thing is how to design the human-machine interaction, right? For certain models like the state tracking dialogue manager models, we talk about frame-based design and flow-based design and so on. And we actually hope it could be more flexible. For example, it could be goal-based design. Instead of saying what the conversation rules and the process for conversation, we can just design the goal of the virtual assistant. And we also hope there will be much richer paradigm of supervising and learning for the virtual assistant. The virtual assistant should be able to learn new concepts and new tasks. And for example, we should be support programming by demonstration. And human teacher can just demonstrate how to do a thing. The virtual assistant then can learn. And so we should, future, we want to empower virtual assistant learn from richer ways or more natural ways. And besides, we feel today's virtual assistant actually don't have enough advanced reasoning. It doesn't have the right attention in certain cases. It doesn't have enough emotional intelligence. It doesn't have enough causal reasoning. Those abilities are not well developed. Besides, we hope today's, in the future, virtual assistant should have principles and guidance. Today, there are not enough guidances, and virtual assistant can make mistakes. And which I'm going to talk more about principles and guidance later. In fact, there is a long-term debate in the artificial intelligence field. How should we achieve better AI? Shall we keep on design specific models like common sense reasoning, causality, intuitive physics theory models, those things into AI? Or shall we just go to build bigger models with more parameters and more training data? And actually, bigger is better is a major dominating idea that drives today's practice. However, we are also not sure whether it will win eventually, especially in more general conversation AI field. So we talked about the limitations. What's the future directions? To answer that question, we actually proposed this conversational virtual assistant ability model to help people to evaluate AI virtual assistant's ability and also give us the guidance of what future should be. And this ability model has 5 levels. It's very much like autonomous driving car. This is not surprising because autonomous driving car is a special virtual assistant. And we have level 1 human agent assist, like cruise control. And we have level 2 partial automation, level 3 conditional automation, level 4 fully automation in design domain, and level 5 human-like automation in open domain. And for different levels, there are different approaches, techniques needed in order to get it done. And we actually are currently at level 3. At level 3 conditional automation, that generally means the virtual assistant can get something done if it has been designed to do it. And in order to do that, the virtual assistant needs to be able to carry out multi-round conversation. It can handle the variation of natural language. It also can handle the variation of the conversation flow. Because even for getting the same task done, there are all different ways the conversation can go. What hasn't been achieved are level 4 fully automation in design domain, and we are still far away from achieving level 5 human-like automation. In order to get fully automation, have virtual assistant help people in design domain for all the tasks and problems. And we need to handle, the virtual assistant need to handle unseen problems and tasks in that particular domain. That generally means it need to have the advanced reasoning ability we mentioned before, how to make some mathematical reasoning, logical reasoning, and causal inference. And it should have the ability to plan for certain task types, right? And for a particular domain, it always need to learn some new concepts. New tasks will come in. This virtual assistant has never seen that task before, but it need to solve the task. So you need to have the ability to learn new concepts and new tasks with simple language. Okay. And the output of this will be a goal-driven virtual assistant, easy to develop, solves quite a lot of long-tail problems without training. And for human-like automation, or probably Superman-like automation, and then the virtual assistant need to be able to handle unseen problems and tasks in open domain. To do that, it need to plan complex tasks and answer basic how questions. For example, if user asks how to make a sugar-free spicy pasta with lamb and with less than 800 calories, this is something nobody has done before. You cannot find the answer on the internet. And then the virtual assistant should be able to put together a procedure to do that, instead of finding the answer somewhere. So it needs to have planning ability and answer basic how questions. And to do that, it needs to process and comprehend abstract and complex information. And more importantly, it should have the ability to learn new concepts, gain new knowledge, learn new skills and preferences from complex instruction by talking with humans. The virtual assistant should have a model of the external world and its own possible actions and try out various alternatives, conclude which is the best way to make that weird pasta I mentioned before. And it should react to future situations before they arise, utilize the knowledge of the past event in dealing with present and future, and even be able to solve problems that's more complex than what they have seen before. Those are the ability of a human being. Those are the future we are working towards for human-like virtual assistant. In the future, we expect developing and training a virtual assistant like teaching a new employee or teaching a child. Conversational AI virtual assistant will learn to work with humans like a new employee or like a child. To do that, they will learn domain-specific knowledge, new concepts, how to do a new task, do conversation with domain experts. So shouldn't be programming, it should be just conversation, like what we do. And the teacher won't be AI engineers or IT engineers. The teacher will just be domain expert. They don't need to learn any development platform. They just need to talk with the virtual assistant. And the virtual assistant will just learn by listening, observing, asking, trying, and working like humans do. And it will learn from penalties and rewards received, like using reinforcement learning techniques we mentioned before. Here we are going to use AI, conversational AI virtual assistant to build conversational AI virtual assistant. This will make it very easier, faster, and cheaper to build new virtual assistant. And we will also we're looking forward to have the virtual assistant to recognize human sentiment within the conversation context. For example, when a user is talking about a car accident in a subtle way, and the bot then respond with empathy tones and comforting words, then they could even engage and influence sentiment. For example, we have worked on how to actually engage user in a conversation and make the conversation better in recent work. And the virtual assistant should also have self-planning skills, and you can just tell the virtual assistant some goal, then it will figure out the process. But like I mentioned, right, how to make a spicy burger with less calorie. And it can collaborate with other virtual assistants and humans, sharing information as well as action plans to solve tasks, right? The virtual assistant and human can work as a team through conversation. That's what we expect in the future. And so far, I have talked about the major learning approaches. Those learning approaches are more data-driven learning approaches. They are very common for now, and we expect they will continue to be common method for conversation AI virtual assistant to learn. However, there is some basic problem with artificial intelligence of natural language processing for data-driven approach. That's called the danger of stochastic parrots, which when the natural language model becomes huge, they become hard to understand, although they say something like human. They have some risks, for example, the tendency of the training data ingested from the internet, those hundreds of billions of training data we get from the internet could encode hegemonic worldview, the worldview of the ruling class. They become the accepted cultural norm, and the virtual assistant trained from those data will take that as a cultural norm. And there are also tendencies of language models, huge models, to amplify the biases and other issues in the training data. And the tendency of researchers and other people to mistake the performance, to mistake the neural network model's performance gain for actual natural language understanding. Okay. Those are the risks in today's approach, and also likely to for the future approach. So although language models, huge neural networks are nowadays can say something like human, and some people even confused and don't know they are not human. However, in serious business contexts, critical situations, those models could be very risky and could make up facts and be very biased. For example, there is a chatbot called Replica. They actually advise Italian journalists to commit suicide because that's the prediction according to the training data. And a few years ago, Microsoft has actually called back a bot before launching it into real production because the bot, the virtual assistant, actually has a series of racist tweets. Those are the dangers of data-driven AI virtual assistant. So in order to maximize the benefit and manage the risk of those machine learning trained models, we actually need to do risk management and build responsible AI for the human society. And the virtual assistant need to be responsible. And I expect the laws will coming out in different countries in the future. They are actually coming out now and in the future to regulate AI systems to be responsible. And for example, my lab is also working on responsible AI, which we call AI for humanity, to support studying and guiding and developing and evaluating AI technologies and applications for the benefit of human society. Hopefully we can get best practice and design new technologies as new ethical challenges arrive. And here are certain important things we are looking at, like being fair and be able to explain the AI virtual assistant, be inclusive, respect the privacy, and being safe, right? You don't want the conversation AI virtual assistant trained on hundreds of billions of training data, eventually advise people to commit suicide or commit murder. And as we combine the future promise of virtual assistant learn from humans through conversation, and meanwhile being responsible, we expect the future will be very good. In the future, the domain expert instead of AI expert could teach conversation AI virtual assistant through very natural conversation. So everyone, including all of you, could be the teacher for virtual assistant. With that, we believe the potential of the conversation AI will be much bigger and also be safer. For example, for food and agriculture expert will be able to teach farming virtual assistants so that the virtual assistant can help farmers to solve their problem. And the doctors could teach AI medical virtual assistants so that they can serve patients. Or the teachers can teach educational virtual assistants so that they can support kids, provide personalized learning. And those are the problems we are looking at. So that's all for my presentation today. Now it's time for questions.
Hello, everybody. This is Mike. Christy and I are going to moderate the Q&A here. I do want to remind everybody, now's a good time to type your questions in the Q&A box. This is a complex topic, and I'm sure some people have some questions, and I just want to encourage you, if you want to ask some clarifying questions or tell us about your experiences with chatbots and with conversational AI, we'd love to hear some of your stories. We do have a few questions. We've had a couple people commenting, just thanking you for the talk, Professor Zhang. So thanks for writing in. I'm going to ask a question from Casey. Clearly, Casey works in the field. Casey's been trying to create a basic chatbot using a chatbot builder with no coding called VoiceFlow. I was wondering if you know of and can recommend any other similar chatbox builders for people who are not as experienced with coding.
So for people not experienced with coding, there are quite a lot of alternative approaches for no-code development. For VoiceFlow, that's the one I'm not very familiar with, but there are other ones. For example, we introduced, I have created a company. That company actually has a low-code development platform. On the other hand, Microsoft, Google, Amazon, they all have various conversation AI development platforms. And it's important if you actually want to build advanced virtual assistant, it's important to understand what are the technologies behind it. Because as I illustrated today, there are so many different technologies, and just no code doesn't tell you what's behind it.
Great. Thank you. I'll take the next question. We have Mark is asking, what are similarities and differences between AI's natural language understanding and other translation apps that translate from one language to another?
So when you do translation, you take one language as input, output another language, right? There are different approaches to do that. And you actually don't really need to understand the language. For example, you can train a gigantic neural network models, which is actually the state-of-the-art translation models, which is somewhat similar to the neural network models we mentioned before, right? And then do the translation. You have input English, for example, output French as training data pairs, and you train a translation model. But usually those translation model popular ones, they don't have internal semantic representation about the language. And the natural language understanding component in the dialogue system we mentioned here do have a structured semantic representation.
Thanks. I have a question from Jenna. Are natural language understanding models designed for particular spoken languages, or are they designed generally and trained on a variety of languages?
Good question. So there are so many different natural language understanding models. There are some models that's trained and designed for a particular language. And on the other hand, you are not surprised for companies that need to serve customers in like more than 100 countries. They don't want to do that for each country. So they tend to train and design on a variety of language. So there are multilingual natural language understanding models developed by companies like Google, Facebook, and so on. They do have that. We also have experience about training multimodal, multilingual language models.
Great. Okay, I'll jump in. We have a question from Alex. Thanking you for your talk. And would you recommend Rasa open source to build chatbots? And what are some limitations?
People like to try open source because they feel they have everything there. You do need to really understand what's going on. Different components of that open source. I think as a learning, and with that open source, it's a learning framework. And then there is a big effort needed to bring it to a production-like system.
All right, we have a big hard question from Gerardo. For these personalized AI learning methods, how can we ensure the information remains correct and ethical? If they are being trained by the individual using it, how could we ensure this learning method does not just emphasize an individual's biases?
That's a good question. There is no solution. That's why I put a slide there. That's something we really care a lot about. And there are a lot of problems created there.
But I'd say, how did the companies manage that? I mean, Alexa and Siri, they must face this. So do they audit the models? Do they have humans in the loop somewhere?
That's why actually production live systems, they tend to use, if they are serious applications, they tend to use template or hybrid-based approach. They don't use the big, gigantic neural network models generate whatever they want to generate. Even for researchers or companies doing research on generate something, they also might have some post-processing to filter out biased statement, dangerous statement, like keyword lists and so on. That's the current solution used by companies. For the companies I work with, they don't use AI generation model. They use modularized approach, more template-based approach for generation. Although the natural language understanding dialogue manager could be more AI, but the generation module tend to be controlled. I even have companies work with company who has to have their lawyer to review what the virtual assistant says.
And I have a question. Like, do you have an example of some techniques that you're working on in the AI for Humanity project that applies to this topic?
And so there are, for my lab, there are 3 things we care about. One is for agriculture domain. We actually have the research funded for building conversation virtual system, support multimodality and multi-sensor based conversation to support farmers. We think to help farmers will eventually help a lot of people because we all need food. Another direction we're looking at is healthcare. Conversation virtual assistant in healthcare field. And the third direction we just started, but haven't done much, but we think very important is conversation virtual assistant for education.
That's great.
Of course,
Exciting.
I'm also open to the audience suggestion. How can we better use AI to serve the human community, right? human society. And farming, education, and healthcare are the three my lab is very interested in.
Well, thank you. Question from Casey. What are your thoughts and insights about the most recent AI text to art software? Not strictly conversational, but fancy generative models. A lot of people have probably seen these generating art and music and things like that.
So those generative models are very much similar to, they are also usually are deep neural network based. So what you learn here today will greatly help you if you want to do text to art software. And what you do is you change the input. Here for conversation, you have the input of text and the output is text. For training text to art, the input is, for example, the caption of the art, then and the output will be art. Then you just keep on training those models. And so behind it, usually the ones that works well are deep learning model based. I know some of those work win certain art festival awards, which frighten artists and make artists very angry. But I think in the future, I would see collaboration between AI artists and human artists. Right? For example, I have friends building an AI virtual AI to generate music, which actually looks pretty good, sounds pretty good. I also played with AI to generate poems, which I feel need improvement, and then I put my human intelligence into it. The best performing results I have seen are usually a combination of AI intelligence and human intelligence.
Yeah, it's an interesting debate. I was just reading that article about the generated art winning the award. Okay, so we have a question from Barbie. At what level are humans at when working with VAs when technology is used to assist consumers in businesses, such as answering questions from humans about commodities via telephone? Many times there are communication problems with these machines to help business customers.
At what level are humans at when working?
Yeah, so what level are the humans at when they're working with VAs?
So there are two types of, if I understand it correctly, there are two types of humans. One are the humans who talk with virtual assistant, right? Trying to get help from the virtual assistant. In business, like, for example, in commerce, those are consumers. Then there are other humans who can help the virtual assistant. For example, the contact center customer service representatives, right? When the virtual assistant talking with customers, if there is any misunderstanding between the virtual assistant and the customer, usually either the virtual assistant should communicate with customer to clarify those misunderstandings, or if it's difficult, you'd better escalate to a human agent in order to avoid pissing off the users.
Okay, thank you. Question from Jorge. As we get closer and closer to stage 5 conversational AI, what types of privacy concerns are we looking at, and how can we as a community make sure these large amounts of data stay as private as possible?
Wow, there are tons of privacy concerns. When a virtual assistant has seen all kinds of conversation data, including private conversation data, for example, virtual assistant talking with patient in health domain, you can imagine how many private sensitive information are there. And if naturally virtual assistant update its model and learn from those conversations, those sensitive private information can be there in the data, right? For example, people have done research on poking those gigantic language models trained from data, and they actually find they can get out quite some private or sensitive information from those trained models. And as community, we want to help to protect data privacy. For certain domains like health domain, insurance domain, commerce domain, there are laws that are required to protection of the privacy. And I don't think we have the right answer yet, but I have seen certain techniques. For example, if PII personal information are evolved, then virtual assistant automatically deletes those information, fill it with fillers, empty notes instead of real information to avoid remembering those private information. However, overall, there is no perfect solution. That's why it's an active research field in responsible AI.
Okay, thank you very much. Looks like we're out of questions and also out of time. So I'm going to wrap it up here. I just want to thank everybody for your insightful questions. Again, my name is Mike Riepe. I'm one of your volunteer organizers. Thank you, Christy, for hosting and co-hosting with me. Can I get a big round of virtual applause for Professor Zhang? Thank you, Professor, for sharing your fascinating insights with us this evening. And I think we mentioned this in the talk, but if you would like to support a good cause related to the topic tonight, Professor Zhang does suggest that you donate to her lab's AI for Humanity initiative. This initiative supports studying, guiding, developing, and evaluating AI technologies and applications for the benefit of human society. We've had several questions about the benefits and risks and privacy concerns and all these things. So I think Diana has dropped a link into the chat here. If you'd like to make a donation, that'll take you right to a spot where you can donate to Professor Zhang's lab. Also, a big round of thanks to the staff of the alumni and special events offices who organized this online forum. Thank you, Diana, Krista, Paulina, and Kayla this evening. Just a few words about Santa Cruz for those alums in the audience. This is move-in week. Please join us in welcoming students back to campus, especially our incoming frosh. Our next Slugs and Steins event is Monday, October 10th. We're not quite ready to announce the speaker yet, but we look forward to seeing you there. Stay tuned for our email announcements with the topic and the speaker. In the meantime, there's some other events you might be interested in. There's a crawl lecture coming up on October 19th, featuring marine sciences professor Mike Beck. Join us to learn about how climate-related coastal disasters increasingly add strain to state and national budgets. Most of the current hazard mitigation relies on artificial infrastructure that further degrades nature, and Beck's team shows that coastal habitats can be cost-effective for building climate resilience, helping create opportunities that benefit both people and nature. On October 20th, we're celebrating 30 years of the Research Center for the Americas. There will be a paid in-person event from 5 to 10 p.m. at the Hay Barn. We'll be honoring civil rights and feminist icon Dolores Huerta with keynote addresses by Cristina Jimenez. Cristina is a community organizer and co-founder and former executive director of United We Dream. Over the last decade under Cristina's leadership, UWD has grown into a powerful network of 1 million members and has played a pivotal role in shifting the narratives about immigrants and immigration, ultimately influencing policy. Cristina was instrumental in United We Dream's successful campaign for President Obama to sign the Deferred Action for Childhood Arrivals, or DACA, into law. There will also be empanadas, desserts, and dancing if you'd like to join us. Also in September and October, you have multiple opportunities to tour Lick Observatory. For $75, you get a 4 to 6 hour tour with astronomy and history lectures and a chance to look through some of the telescopes. All you have to do is drive to the top of Mount Hamilton. For these events and others, see calendar.ucsc.edu. On behalf of UC Santa Cruz Alumni Association, thank you for joining us tonight, and please come back in October at 6:30 p.m. for our next virtual event. Thank you, everybody, and good night.